In our current situation, we are consuming the Earth's natural energy resources very quickly, and thus the primary energy reserve of the Earth will almost be depleted in a few years' time. It will result in an energy crisis. Primary energy is classified into two types: non-renewable energy like fossil fuel and coal, and renewable energy like wind and solar energy. Now let us take a look at the energy consumption in different areas. As we see, the household sector consumes around 10% of the total energy. As our theme is energy at home, we make this sector our target. Our home is our hostel 6 degrees, so we focus on it. We did a survey on the hostel residents. We asked them what is one of the major issues they face in the hostel. We found that out to be the discomfort they face due to high temperature. We can see the majority reply with the temperature being uncomfortable. Based on this, we did a research on Singapore temperature. During the day, the temperature is relatively higher than at night. We do another research to find the temperature at which people are comfortable. We can see that it is between 20 and 30 degrees Celsius. Based on this problem, we brainstormed different ways to reduce the ambient temperature of the house. Way 1 is to use a flowing material to transfer heat out of the house. Way 2 is to use a material which absorbs the energy from the room. Way 3 is to reflect the sun's rays and preventing them from entering. And lastly, to use an insulated system to stop heat exchange between the house and the surroundings. To explore these ideas further, we do functional analysis and we come up with a functional chart to help us with ideation. We focus more on way number 2, which was to somehow absorb heat from the house. We realized our design needed to address different aspects, so we explored them. Consider different aspects like efficient installation, perhaps on the ceiling, above the window, below the window, or on the floor. Then we consider how to make more efficient airflow. And the easiest and most feasible way to do this is to use fans. So we consider many different kinds of fans. We consider the standing fan, the ceiling fan, and also the tower fan. For our design, we also need to consider appropriate material for heat absorption. It's good to use phase change material which will change its phase in between 20 to 30 degrees Celsius. It's a disadvantage to use liquid to gas because of sudden pressure increase and other factors. But this is not so in case of solid to liquid systems. So it is better for us to use a solid to liquid phase change material instead of a liquid to solid phase change material. Our solid to liquid phase should have high heat capacity, must be reusable, and also should have a reasonable cost. To make our phase change material, or PCM for short, reusable, there must be a regeneration system. So we consider transferring heat from our PCM to another flowing material, perhaps water. We can also drive the heat away from the room with a better ventilation system. Based on all this, we draw up a working mechanism chart which helps us choose our final design and product. Based on the working mechanism, we decided to adopt BioPCM as our material to absorb heat. Based on the calculations, we were able to figure out that around 5 kg of BioPCM is enough to keep an average room cool. We also decided to choose evaporation of water to cool down the BioPCM and turn it into solid again. The heat energy released from the BioPCM will be absorbed by the water, and based on our calculations, half liter of water is enough to absorb this amount of heat and cool down the BioPCM.
This is a model of how we will use water evaporation to cool down our BioPCM. The BioPCM plates are represented by the acrylic plates that are in the center of the prototype. As you can see, we use a water pump to continually pump water up to the water storage tank, which is then trickled down through small holes onto the BioPCM plates. The water pump will not be continually working, but rather only when it is necessary. The BioPCM plates are actually supposed to be cooled down naturally at night when the temperature is lower. However, this cooling mechanism serves as a complement to cool it down when it is insufficient. We hope this product will be a breakthrough in the cutting-edge technology in SUT.